Hello students, welcome to Learn RTL coding from scratch. Today we are going to see 1:8 demultiplexer. Before entering into the session, please subscribe my channel PLSI with Dr. Leena. So what is demux? A demultiplexer is a digital circuit that takes one input. See, it takes one input, it routes it to one of the many output. It routes the one input to one of the many outputs and selection is controlled using select line. Here you see select lines are there. And when we see demux and mux, mux is the one which have many inputs and one output. Where demux, it has one input and many outputs. Demux is opposite to a mux. And now we are going to see 1:8 demux structure. In this, we have one data input that we are representing as D and three select lines, that is we are giving it as cell 0 to 2, and 8 outputs, that is we are representing it as Y 0 to 7. Y 3 select lines, that is 2 power n is equal to number of outputs, 2 power 3 is equal to 8. So 3 select lines can select one among 8 outputs. So we are going to see the RTL code and test bench for this demultiplexer. Yeah, now we are going to see the RTL code for 1:8 demultiplexer. In this, first we are writing the module and then we are giving the module name and opening the bracket. After giving the module name, we have to give the inputs and outputs. Here we have D as an input and cell 0 to 2 as a input, and we have output Y that ranges from 0 to 7. Now we are going to give the input using wire, that is 1 bit input signal D that carries the data to be routed. And next one is we are giving the 3 bit select signal cell. It is used to choose which output line gets the input. We are going to give the output, that is 8 bit output bus Y. It is defined as rich because it is assigned inside an always block. We have already seen all these clearly in the previous videos. And then we are going to end the port declaration list. Next, what we are going to do? We are going to do behavioral modeling. And in the behavioral modeling, we are going to do combinational. So we are going to give always at, we are opening the bracket and putting the star and closing it and beginning. So it creates a combinational logic block that executes whenever any input changes. And the next thing which we are going to give is Y is equal to 8-bit binary 0. Why we are assigning this? We have already seen it in the previous video, that is, first it sets all 8 outputs to be 0 by default to avoid the latch creation. Next is case cell. This one checks the value of the select signal to decide which output to activate. Now you see, first we are giving 3-bit binary 000. If the cell is 000, assign input D to the output Y0. That is, input D is assigned to output Y0. And next one is 3-bit. And if cell is 001, then assign input D to the output Y1. Similarly, for 010, 011, 100, 101, 110 and 111. That is 3-bit binary, and if cell is 111, assign the input D to the output Y7. The next condition default, this why we are using means if cell has an invalid value, then it keeps all outputs at 0 for safety. So that we are using this condition, and then we are ending the case and we are ending it. Finally, we are ending the module. This is the 1:8 Demultiplexer RTL code. Now let's see how to write the test bench. Yeah, now we are writing a test bench for 1:8 demultiplexer. That is, the first thing is we are going to give the module and we are going to give the module name. What I have done is I have given the module name which I gave in the RTL code and I put underscore TB for the test bench. And then next we are going to give the inputs and outputs using reg and wires. We already know why we are using reg and wire. Yeah, look at this. First we are going to give 1 bit input D using reg, and next we are going to give 3-bit cell using reg. Then we are giving the output Y, that is 8-bit using the wire. After giving all the inputs and outputs using reg and wire, what we have to do? We are going to instantiate. That is, we are going to bring the module or RTL code inside this test bench. The first thing what we are doing is we are giving the module name which we have given it in the RTL code, and then we are giving UUT, this is unit under test, and opening the bracket. Next we are connecting the test bench input with the module input, and then test bench cell with the module cell, and then test bench output with the module output. We are closing the instantiation. We have assigned our inputs and we have instantiated it. After doing all these, what we must do? We are entering into the logical operation. So we are initially beginning it. And then first what we are doing is we are setting the input D at high to test the output routing. So initially we are keeping the D at high, and then we are giving the conditions. That is, look at here, we are testing all select lines. The first thing is when cell is 0, 0, 0, it selects the output Y0 and waits 10 time units to observe the output. And next, when cell is 0, 0, 1, it selects the output Y1 and waits 10 time units to observe the output. Similarly, when 0, 1, 0, it selects the output Y2 and waits for 10 time units for observing the output. Similarly, it will be doing for all conditions. And then finally, when cell is 1, 1, 1, it selects the output Y7 and waits for 10 time units to verify the final case. And then it stops the simulation after all select values are tested. Then it ends, and finally it ends the module. So this is the test bench. Here the first it assigns the inputs and outputs using reg and wires, and then it instantiates the RTL code into the test bench, and then in the initial condition it makes the input D equal to 1, that it makes it high, and then it checks all the test cases, and finally it ends the operation. So this is the RTL code. Now let's see how the output waveform is. Yeah, now we can see the output waveform. See, first thing is D is equal to 1, and when D is equal to 1, when cell is 0, 0, 0, it selects Y0. When cell is 0, 0, 1, it selects Y1. Similarly, it does for all, and when cell is 1, 1, 1, it selects Y7. And here only one bit becomes high at a time. So we can see it in the waveform window. Look at this. The D is 1. So it is 1 for every case. Then these are all cell inputs. So in the cell we are giving 0, 0, 0, look at this. It selects the Y0 in the output. And when cell is 0, 0, 1, it selects Y1 in the output. And when cell is 0, 1, 0, it selects Y2. And when cell is 0, 1, 1, it selects Y3. And when cell is 1, 0, 0, it selects Y4. When cell is 1, 0, 1, it selects Y5. When cell is 1, 1, 0, it selects Y6. And when cell is 1, 1, 1, it selects Y7. So this is the waveform of the 1:8 demultiplexer. So students, today we have completed the demultiplexer, and next video we will be seeing the encoder, decoder, comparator, ALU and lot more codes we are going to see. So if you want to learn the RTL coding from scratch, please subscribe my channel VLSI with Dr. Leena. Thank you.